Hello everybody. So today we're going to take a look at finishing up the section on the elimination method to solve systems. So if you remember what we took a look at last week, we could add and subtract equations just like we can add or subtract numbers. So our goal here is to have something like this where the coefficients of one of our variables are equal, so that when we subtract them or add them, they can cancel out and we're left with only one variable that we can just solve for, and then after that we can substitute in to find the other one. We also learned that if we have a system where there's not any equal coefficients like this one here, we're going to have to multiply the equation by some value in order to make it so they both do have an equal coefficient. In this case, we multiplied 1 by 5 and 1 by 3 to get 15x, which we could then subtract to have the x's cancel out. So all I'm going to do today is I'm going to go through two examples. One is going to involve fractions, because there's a nice trick to eliminate fractions when we're doing these types of questions, and then we'll do a word problem to finish things off. So our first example is going to look like this. Of course, I'll be asking you to solve a certain system, and the system is going to look like this: 2/3 x minus 1/2 y equals 4, and 1/2 x plus 1/4 y equals 5/2. Okay, so a little more difficult perhaps than what we've seen before. But what we're going to do here is, when you have fractions, the trick to get rid of them is to multiply the equation multiply each equation by the lowest common denominator. And when we do that, it'll actually end up getting rid of the fractions. Okay, so if we take a look at the first one, the first equation here, we have a 3, we have a 2, and this is a whole number, so we don't have to worry about that one. So we have a 3 and a 2 for the two denominators. Of course, the lowest common denominator between those two is going to be 6. So what we're going to do is I'll take my equation here just to write it out again. 2/3 x minus 1/2 y equals 4. And because it's 6, our lowest common multiple being 6, we're going to multiply both sides of the equation by that. Okay, so on the right side, it's easy enough. It's going to be 24. 4 times 6. On the right side, we have to remember to distribute. Okay, so on the left-hand side, what we'll do here is I'll do 2, and then I'll do 2 times 6 there, over 3x minus 1 times our 6 over 2y equals 4 times 6, which is of course 24. Okay, so now what we can see here is we get 2 times 6, which is 12, divided by 3, of course, leaves us with 4. So it simplifies. Another way you could kind of visualize this is 6 divided by 3. Of course, that's 2, so they can simplify to just 2. So we get 2 times 2, which again is just 4. So we get 4x. And then over here, 1 times 6 is 6, divided by 2 gives us 3. Again, you could just recognize that this 6 and the 2, 6 divided by 2 simplifies to 3, and then 1 times 3 gives us 3. Either way is fine. Equals 24. And as you can see, we have no fractions left over, and it's still the same equation. We'll do the same for the next one. So over here we have a 2, we have a 4, and we have another 2. So our lowest common multiple there, or our lowest common denominator, is going to be 4 for that one. So I'll do the same thing over here. So I'll get 1/2 x plus 1/4 y equals 5/2. All right, so again, everything on this side by 4, and everything on this side by 4. Over here on the right-hand side, now we have a fraction, but it'll still work out the same way. We won't have a fraction left over there. And of course, we're going to have to distribute that 4. So what we end up getting here is 1 times our 4 divided by 2x plus 1 times 4 again. That's going to be over 4. Y equals 5 times 4 all over 2. And of course, these are all going to simplify quite nicely. So we have 4 divided by 2. Of course, that simplifies to 2. 4 divided by 4 simplifies to 1. And 4 divided by 2 simplifies to 2. So we get 1 times 2 is 2. It's 2x. We get 1 times y, which is just 1y, or just y. And then we have 5 times 2, which of course is 10. So now we have our 2 new equations in our system. We have 4x minus 3 equals 24, and we have 2x plus y equals 10. So now we're kind of back to this previous example here, where we had only whole number coefficients, but none of them were equal, right? So we have a 4x and a 2x, so we can't straight up just eliminate those. And we have a negative 3y and a y, so we can't just straight up eliminate those. So we're going to have to multiply either one or both of these equations by some number in order for them to equal and be able to cancel out. That doesn't matter if you go to eliminate x or if you go to eliminate y. It doesn't really matter. Here, I'm just going to eliminate y. So what I'm going to have to do here, I already have a negative 3y there, and I have a positive y here. So if I just multiply this equation by 3, I'll end up getting a positive 3y, which I'll be able to use with this 3y in order to cancel them out. So I'll just come over here, make a little note, multiply by 3. So if I multiply everything by 3 here, it's going to look like, I'll just rewrite it, just to be a little easier to see. So just like I was multiplying by 6 and 4 up here, I'm going to come down here and multiply by 3. Okay, so I get 3 times 2, well 3 times 2x, of course that gives me 6x. 3 times y is 3y, and of course 3 times 10 is 30. Okay, so I have my final 2 equations here and here. So what I can do now is I can stack them on top of each other and perform our elimination. So we have 4x minus 3y equals 24 from the first one. And then we have 6x plus 3y equals 30 for our second one. And the question is, do I now need to add these to cancel them? Or do I need to subtract these to cancel them? Well, if I have a negative 3 here and a positive 3 here, of course that means I'm going to need to add these two equations, because if I did negative 3 minus 3, I'd get negative 6. They won't cancel out. But if I do negative 3 plus positive 3, I'll get 0y, which of course is them canceling out. So I got 4x plus 6x. Of course that is 10x. As we just said, we're going to get negative 3 plus positive 3 is 0y, which is a cancel. And then we're going to get 54 over here. Okay. So of course, simplify that a little bit. We have just simply 10x equals 54. And we can divide by 10 on both sides. We'll get x equals 54 over 10, which is equal to 5.4. Okay, so that's our value there. So what we'll do from there is we can just substitute in this x value into one of our original equations. So I'll just take one of our original equations from the very start of the question. So that's the first answer there. And the second one, I'll just do 2/3 x minus 1/2 y equals 4. So I'll take this x and I will substitute that right there. So we'll get 2/3 times 5.4 minus 1/2 y equals 4. And if we do the math there, we'll simplify all of that. So we'll end up getting a value of y of negative 0.8. If we multiply these together, subtract it from 4, and then divide by negative 1/2, we'll get this value for y. Okay, so then that's our solution. A value for x and a value for y. And there you go. So definitely a little harder. This one involved all of the worst case scenario. Had fractional coefficients. Once we got rid of the fractions, we didn't have any equal coefficients, so we had to multiply them by a constant, and then we had to eliminate. So definitely a trickier question there. Okay, so that's how you approach problems like that. Keep an eye out for your fractional exponents. Make sure to multiply them by their lowest common denominator to get rid of the fractions. Okay, so let's do one word problem, and that'll be it for this week. So this one, a metalsmith wants to make a 100-gram bracelet with a 50% silver content. He has 2 metals to use. A 60% silver metal, which of course is too high, and a 35% silver metal, which of course is too low. And the question is, how much of each should he use to make the 100-gram bracelet? Okay, so 2 ideas here. The bracelet must weigh 100 grams, and the bracelet must also contain 50% silver. So of course we don't have a 50% silver metal to use. What we have is a metal that is too much silver, and we have a metal that is too little silver, and it makes sense that some combination of those two together will give us exactly a 50% combination. So not only do we have to figure out what that combination is, but we have to make sure that that combination weighs exactly 100 grams. Okay. So if there's 2 main ideas that this bracelet has to obey, and again, it has to be 100 grams and it has to be 50% silver. If those are 2 requirements, it would make sense that we could make 2 equations to represent that. Okay. So again, that's a word problem, so we're going to have to go all the way back to the first chapter, or the first section in this chapter, where we looked at developing our own system of equations to start, because we don't have any here, it's just a word problem. So that's our first step, is we need to first make our 2 equations that deal with those 2 requirements. Okay, so what I'm going to do, I'll pick some variables here. So I'll say let S equal grams of the 60% metal, and I'll say let T equal grams of the 35% metal, because we want to know how much grams he needs to use of each metal. So we need to make sure that the variables we pick are the actual thing we're looking for, which in this case, the thing we're looking for is grams of the metal. How much grams of the metal does he need to use? Okay, so the easiest one to set up first is going to be the one that says the bracelet must total 100 grams. So it doesn't matter how much of the 60% metal we use, and it doesn't matter how much of the 35% metal that we use. Well, it does. It does matter how much of it we use, but in order to set up our first equation, all we know is that it needs to weigh 100 grams. So it doesn't matter how much 60% we use, doesn't matter how much 35% we use, they need to weigh 100 grams. So if S is the grams of the 60% and T is the grams of the 35%, well, that just means S plus T has to equal 100. All right, that means the grams of the S metal, the grams of the T metal have to add to 100%. Okay. And the next one. So half of the bracelet has to be silver, right? Half the weight of that bracelet is going to be silver. So if the total weight of that silver is 100 grams, it's a 100-gram bracelet, half of that is going to be from silver. So we know that 50 grams has to be silver. But now this is the tricky part for the next part of the question. So let's take the 35% metal, for example. We can't say all of T is going to be silver because, as we know, the T metal, which is 35%, only 35% of it is going to contribute to this 50 silver. So to take 35% of T, we just multiply it by 0.35. So whatever amount of T metal we use, that's the 35% metal, whatever amount of metal we use from that, we know 35% of it is going to be silver. And by the same justification, for the S metal, 60% of it is silver. So what we have set up here is silver content. So this is total weight, this is silver content. Okay, so we know from the S metal, 60% of it is silver. From the T metal, 35% of it is silver. And this is the total silver concentration. And what we know about the bracelet is 50% of it has to be silver. And if it's a 100-gram bracelet, 50% of the 100 grams is going to be 50. Okay, so hopefully that makes sense. And what we have here is our system. Okay. So obviously here we don't have any equal coefficients. So we're going to have to multiply something here in order to eliminate it correctly. So what I'm going to do is I'm going to take the first equation here, and I'm just going to pick something to eliminate. I'll just eliminate the S. Okay. So if I have a 0.6 here and a 1S here, I can just multiply this equation by 0.6. And what I'll be left with are two equations that have 0.6 as the coefficient in front of the x. Eliminate s. So what I'm going to do, I'll take my s plus t equals 100, and I'll just multiply both sides by 0.6. Okay, and when I do so, obviously 0.6 times s is just 0.6s, 0.6t equals 100 times 0.6 gives me 60. Okay, so I've changed this equation into this equation now. So now I can stack them up and I can do some elimination. So I'll take my new one up here, my 0.6s plus 0.6t equals 60. Stack it on top of my 0.6s plus 0.35t equals 50. And again, the question is, do I need to add these to cancel them, or do I need to subtract them to cancel? In this case, I'm going to need to subtract because I have a positive 0.6s here, a positive 0.6s there. If I added them, I would just get 1.2s, which is not a cancellation, but if I subtract them, I get 0s, which is a cancellation. Alright, then I get 0.95t equals 10. Or whoops, I'm subtracting, not adding. I just said I'm subtracting. Jeez. So I get 0.25t. Alright, so if I clean that up, I get 0.25t equals 10. And that means I have to divide both sides by 0.25 to cancel them out. And I simply get t is equal to 40. And remember, we're talking about grams here. So if we go back, I said let T equal grams of the 35% metal. So we know we're going to have to use 40 grams of the 35% metal. And now we just need to substitute for the last one. So we'll take the easy equation there. S plus T has to equal 100, right? Both metals have to add to 100 grams. So I can just take this, make my substitution here. So I get S plus my 40 grams. And to simplify this, I had to subtract 40 from both sides. And I get S equals 60 grams. So we get an answer, of course, of therefore metalsmith must use 40 grams of T, which was the 35% metal, and 60 grams of the 60% metal. And if he does that, as we saw, well, of course, if he uses 40 and 60 grams of each, that bracelet is going to contribute or total to 100 grams, which is the first requirement. And the second requirement was that the total bracelet must contain 50% silver, which, as we've seen, will work because we set up that equation accordingly. Okay, so tough question, for sure. But that's all I have for you guys this week, so we can go and finish up that homework. So that was on page 437. And last time I got you guys to work up to question 8. So for this one, let's do question 9, question 10, 12, 13, 20. So 5 questions this week. Okay, so go ahead, work through that. If there's any questions, make sure you guys reach out, email me, or let me know in the Discord, and I can help you out there. And again, we are coming back into school now, so if you had any concerns about your math mark or if you're missing anything, and I haven't already contacted you or your parents to get you into the building, please let me know through Discord or through an email if you'd like to come in, and we can see what we can do about your grades, okay? So that's all for now. See you next week. Bye.